We're going to start talking about sequences. We have arithmetic and geometric, but to go along with our y equals mx plus b, we are going to be focusing only on arithmetic. So here is our little notes foldy. So we're going to fold it over. You can go back and you can cut along the dotted lines on this top part. So let's first talk about what is an arithmetic sequence. Well, you've been looking at sequences most of your life, even in kindergarten, right? And a sequence is an ordered list of numbers. An ordered list of numbers. And there's typically a pattern associated with that sequence. So when we look at an arithmetic sequence, this is probably what you were used to in elementary. An arithmetic sequence is a sequence or an ordered list of numbers in which the difference meaning subtraction, between B/W is the abbreviation for between consecutive means in order, 1, 2, 3, 4, 5, between consecutive terms is constant. So this is a really fancy way of saying slope, okay? Your arithmetic sequence is going to have that difference, which is AKA your slope, is constant. So how the numbers change each time is the same. So here is an example of an arithmetic sequence. 0, 5, 15, 10, 15, 20, and 25, and so on. So there is a pattern going over through this. So we can see now, the other thing I want you to keep in mind when we look at a sequence is that if we are to make a table, okay, these values, these are going to be our y values, and x, these are going to be our terms. And we always start with 1. That's going to be the key difference between a sequence and y equals mx plus b. And this is called our term. They usually use n. So if we look at this example, tell whether the sequence is arithmetic. So we're looking, are we adding and subtracting the same amount each time? So from -7 to -1, this is +6, and -1 to positive 5 is +6, +6. So this is an arithmetic. Yes, this is arithmetic. Okay, and then it also says, what are the next two terms? So if I said 17 plus 6, my next term would be 23, and 23 plus 6, my next term would be 29. When we talk about this right here, this +6 piece, this is what we call our common difference, which is a special way of saying our slope, right? Because if we went ahead and we made a table, 1, 2, 3, 4, 5, right? So we're changing x is 1, changing y is 6. Is this one arithmetic? This is +3, but then this is +12. So we can actually stop there if we wanted. This is not arithmetic because it doesn't, think about when we talked about, is it linear? It had that same slope every time. This one doesn't. All right. So when we look at graphing, this middle section, graphing an arithmetic sequence, all right, so to graph this, we need to create a table of values. Okay, and remember, our table is going to start with 1. It starts at 1, not 0. So here is a little example for you. Here's my x, here's my y. Keep in mind, sometimes our x, sometimes they use n here, right? Because they call this the term number. So I have my first term, my second term, third, fourth, and fifth. And if we use this same pattern that we had up here, you can see again, there's our sequence. So to graph that, we need to keep in mind that this is a table, right? 1, 2, 3, 4. This is not 0, negative 2 down here. This is, in fact, 1, negative 2. 2, 1, 3, 4. 1, 2, 3, 4. 4, 7. Okay? This is a table, so this is going to be discrete. Okay? So the big thing is you need to make that table, and you need to start with 1, not 0. So this is going to be 1, negative 9. Kind of estimate that almost to that line. 2, positive 1. 3, positive 11. 4, positive 21. 5, positive 31. And we can see again, these are linear. They make a line. So these are arithmetic because they're linear. Okay, our last section says writing our rules. And this is something we're going to focus on in class tomorrow. All right, so the nth term of an arithmetic sequence with the first term a sub 1. Okay, this is similar. So squiggle equals is like similar to our b, right? Except instead of being 0, 1 or 0b, it's going to be 1 something. Okay, because remember, when we do sequences, we always start with 1 instead of 0. And D is our common difference. Common difference, this is like slope. So our formula is A sub n, where n is the same as x, right? We talked about that a minute ago. A sub 1 is equal to A sub n. We're going to write it first, and then we'll label it, plus n minus 1 times D. Now, if you don't like the D at the back, you can go ahead, you can write it at the front, and then it looks like a distributive property. So A sub 1, this is our first term. And then N is our X, or our term we are finding. And D is our common difference, aka our slope. Okay, so keep in mind this is like, it's very similar to y equals, I'm going to write it backwards, b plus mx, where we're multiplying, that's our m or our d, and our first term. This is also like function notation, right? F of n, f of x, and we're going to practice that. So let's look over here, write a rule for the nth term. Find A sub 100. So A sub 100 is like saying F of 100. This is putting 100 in place of X or N. Okay? So we have to figure out what's going on. So we're going to make a table always. 1, 2, 3, 4. This is my N or my X, and this is my Y. So my A sub 1, that's what we need. It's like finding when we were writing our M and our B out. So our A sub 1 is 3. Our common difference or our slope, what's happening? We're adding 10 each time. Your difference can be negative. So if we wanted, we're going to plug these in. So if I want A sub 100 is equal A sub 1, 13, plus I want my N value is my 100 from here, minus 1. And my common difference was 10. And then you can always go to your calculator, and we're going to plug this in, 13 plus, you can do 100 minus 1 in your head, or you can type it in, times 10, 1003. So that means our 100th term is equal to 1003. Let's try another one. Again, A sub 1 is that first term. Your common difference or your slope, what are we doing each time? 1 to 6 is plus 5, plus 5, plus 5. So A sub 100, and we're plugging back in over here. So A sub 1, 1 plus N was 100. It's whatever number they want you to find. Minus 1 times our D is 5. So I could say this is 99 times 5. So 1 plus 99 times 5 is 496. So in this pattern, my 100th term is 496. So again, if we graphed that, if my x was 100, my y would be 496. Here we have, again, a sub 1 is negative. Be careful. Make sure you pay attention to those. Negative 5. What's happening? Well, negative 5 to negative 7 is minus 2, minus 2, minus 2. So our common difference is negative 2. So I can say a sub 100 is equal to a sub 1. 100 minus 1, because we're still looking for that 100th term, times a negative 2. Oh, I forgot my plus sign. Let me fit that in there. Negative 5 plus. So I can say negative 5 plus, I know that this is 99 times negative 2. Don't forget your negative when you put it in your calculator. Let me make this so you can see this. My light went off for a minute. So again, negative 5 plus 99 times negative 2, negative 203. So this, if we graph this, this would have a negative slope. It would be going down. We're going to do some more with this tomorrow. Make sure you put this in your journal. Have a great evening.